And then let's look at this next part, which is about drawing more complex shapes. So drawing a shape like this Christmas tree. So we can, just like in Illustrator, if you've used a program like that, or something like Inkscape, if you've seen that before, you can have these drawing programs where it's possible to click on the screen and sort of define a shape with a number of control points. You kind of click and then, oh, that's a really wonky Christmas tree. In Illustrator, you can sort of draw a tree by kind of clicking these points and making a shape out of it. We can do something similar in P5.js with the beginShape and endShape functions. So in those drawing programs, each of these points, kind of think of it like one of those drawing by numbers things you might have done when you were a kid, like where you just follow from 1 to 2 to 3 to 4, and you end up drawing a shape. Each of these is called a vertex. So we're going to create these vertexes in P5.js manually. So the code for drawing that Christmas tree is actually this. It's just beginShape and then placing all of the vertexes in order, and then endShape. And there's an example of that. That's actually pretty tedious to do, but if you take the time, you can then do things like have like a pine tree stamp or something like that. So you could have a more complex shape that gets stamped onto the canvas. There's another one you can use called curve vertex, and that's also fun to play around with. So why don't we actually try just doing a little example where we create a shape just with some random curve vertexes and see what sort of effects we can get out of that. So I'll create a new sketch. And I'm just going to do this once. I'm going to say no loop at the end of my draw function. So it draws once and then stops. I'm going to say beginShape and endShape, close. And I'll just start by doing a few vertexes manually. So curve vertex 10, 10. Uh, 380, 350. 200, I'm just making these numbers up. 250, 40, I don't know. So I get a shape like that. What I'm going to do, just to show you how that, where those points are, I'm going to copy those curve vertex ones, and then down below it, I'm going to just draw a point on each of those spots. So I'm going to say draw points. Draw points of the vertices. And I'll just copy and paste that, but change the function from curve vertex to point. And I'll change my stroke color to red so we can see them. show it. Maybe I need to make the stroke weight a little thicker. There we go. So they were just too small to see on my screen. So you can kind of see, like, as I place the point, it sort of generates a smooth curve between them. So this is an easy way to sort of do curvy lines. So Gabby, with your waveform, you could have used curve vertex there. Did you? I think you used points, didn't you? Yeah. So rather than just drawing points, if you'd done beginShape and endShape with a curve vertex, it would have been a smooth line. I'll just show you the effect of changing this close. So if we change that to open, what we get is a shape that's open instead of closed. So it is quite tedious to do these sorts of things. So like one thing you can do is you know, just randomly place them. So I'll make a function called place random or random vertex. And I'm going to do this 100 times. So I'm just going to make 100 random vertices. So if I want to do that in a for loop, I start at 0 and my test is I is less than whatever number I want, right? So it's 100. And I'm going to, before I do this, translate to the middle of the screen. And I'm going to make my random numbers here. I'll just make them go from -100 to 100 for a start. So I kind of get this weird jumbly scribble. So this could actually be quite an interesting effect if I wanted to make a drawing program, say, where you could kind of draw with a scribbly line. So rather than translating to width over 2, height over 2, if I was to translate to mouse X, mouse Y, and I'll take away the fill, Probably, maybe I need my, oh, I've got no loop there, so that's not going to work. So I want this to loop. Now you can see this kind of scribble follows me around on the screen. And to make it a drawing program, I want to get rid of the background, get rid of clearing the background, and probably I only want to do this if the mouse is pressed. If mouse is pressed, yeah, so now when I press my mouse, I get this scribble. Now I think it's probably a bit large, the amount of scribble that I have there. I'm going to make the canvas a little larger. I'll make it 600 by 600. So what I'd really like is that the size of that scribble is controlled by this number here, right? It's the minus 100 plus 100. That's how large the extent of that scribble is. What I would really like is to make that an argument to the random vertex function. So if I put an argument here called size, or s, I can use that in my random function here. I can put minus s, positive s on each one. And when I call it, I can give it something smaller, like let's say 10. And I'm going to just set the initial background of my canvas to be white. So I've got this kind of scribbly line going on. And now because I've made that an argument to the random vertex function, I can actually change that each time. So I can say let size equals the distance from mouse x, mouse y to p mouse x, p mouse y. So p mouse is the previous mouse position. So mouse x, mouse y is the current mouse position, and p mouse py is where it was last frame. So if I go s times 10, say, what I should get is this kind of interesting effect where the faster I go, the larger the scribble gets. If I draw really slowly, I get this little scribble, and then if I go fast, it gets larger. Maybe I'll take away the times 10. It seems like a bit much. Let me find a way I'll just try and share this link with you if you want to actually see an experiment with the example yourself later. If I go to Go Soapbox, I'll just create a forum for today's tutorial. So if I sign in, create DXB211 tutorial 7. So that's the number there, 981211070, and if you want to grab that, just use that code at app.gosoapbox.com. And yeah, post in any examples that you guys come up with as well. I should have remembered to make the Go Soapbox for today before we started. Has everybody got that? I'd just like to give some commentary on the code itself. So I think there's just a few interesting points about this example that are worth making. I think the first thing is like defining a function. Don't be afraid to use that yourself. Like you can define a function to do anything you like. And it's actually a really good way to experiment with a little part of your code. So here, if I felt that the way this random vertex worked wasn't exactly what I wanted and I wanted something else, I can leave that code there and I can actually go in and make another function. Like I might decide that I want them to be spiky. So in that case, I could make another function called random spiky vertex. And use the same basic pattern, but just change the kind of vertex that I draw. So instead of drawing a curved vertex, if I draw just a normal vertex, then I'll get this kind of spiky effect. And so that means I haven't taken away any of my old code that's working and I know kind of works, but I can experiment with something new. So here, all I have to change in the draw loop is instead of calling random vertex, I call random spiky vertex. And it's a slightly different look that I get from that function. Yeah, so functions are a great way to encapsulate, is the word we use, a bit of code and reuse it in different ways or experiment. It makes your life a lot easier. The second thing that I think was worth kind of just going over again here is this use of an argument to a function. It's a bit like what we talked about with the variable. You know, instead of having just the number 8 as the number of petals in my sketch, if I turn that into a variable, it lets me change it, and it's the same thing with a function. So I might have another function here called drawFlower. And I can give it an argument for the number of petals that I want to draw. And if I actually go back and get my code from the earlier example, is it still there? I think I saved it. That's the one I'm on now. Oh well, I'll just redo it. It won't take long. Let A equals 360 divided by num petals for let I equal 0, I is less than the number of petals, I plus plus. Rotate radians A, ellipse. I'll make this ellipse a little bit smaller, so I'll make it something like that. Now if I draw a flower where the mouse position is, instead of a random spiky vertex, and I can put in 8 if I want flowers with 8 petals. I get my flowers, but I might also want to change the number of petals depending on how fast it's moving, right? Could be an interesting effect. So I could say int s times, let's try it, s times 10. And actually what I'm going to do here is not get rid of the fill. So I'm going to keep the fill so we can actually see the flower. It's freaking out because it's drawing so many petals. It can't keep up. So s times 10 is too many. Yeah, so when I go slow, it's only got 1 petal, then 2. And it gets more the faster I go. It's quite an interesting effect. I mean, maybe it's not something I would go on with, but look, all we had to be able to do in order to achieve this is encapsulate that code of drawing a flower into a function and just give it that one parameter, that one argument that adjusts how it behaves. Then we have so much control and flexibility over what we do with our code and the kind of experiments we make. So it's a very, very powerful approach to your code. Any questions there? Pretty much near the end of the tutorial, so we can take a few open questions at the end. Yeah, okay, so the question there is if you wanted to alternate between the functions every 10 frames or something, what would be the easiest way to do that? Great question, and another great reason to keep things in functions, because you can easily switch between things in the code as well, yeah. So probably the easiest way to do that, and we sort of covered this in last week's tutorial with the time, with the frame count. If I go if frame count so firstly I'll just do it every frame. Okay, so this is going to look really randomly, but then we'll adjust up to every 10 frames. So if frame count, can you remember the operator that we use from last week? Yeah, it's a bit like division, but it's sort of the complement to division. It's the remainder function. So we want to divide by some number and get the remainder. We use this one. It's just the percentage sign, but it means remainder in JavaScript. So if frame count remainder 3, because you said every 3, sorry, remainder 3 because we've got 3 different options. So we want to go 0, 1, 2, 0, 1, 2. Frame count remainder 3 will give us that. So if it equals 0, then I can draw my flower. Else if frame count remainder 3 equals 2, equals 1, sorry. Then I'll draw the spiky vertex. Was it random spiky vertex? S, and then else, if it's not 0 or 1, it's always going to be 2, so the only other case I need to deal with is drawing a random vertex. S. Oh yeah, look. So every now and again I'm getting a spiky one, but it doesn't seem like it's doing it consistently. I think it may be that the flowers are sort of larger. Yeah, so can you see there where my mouse is? It is drawing the other ones. They're just actually getting covered up by the flowers. That's the problem. But it is doing that flipping between thing. If I wanted to do it every 10 frames to flip, all I need to do is I need to divide frame count by 10 first. So it's at this point it's actually less work to use a variable. So I would say let choice equals frame count divided by 10, remainder 3. And I'll just turn this into an integer. I want it to be a whole number. Thanks, Matt. And then I would say if choice equals 0, choice equals 1, and then otherwise. Yeah, so I've got the behavior there. It's every 10 frames. Good question. Okay, I might leave it there. Happy to answer any questions after as well. So for your homework, just remember, you know, like go back to that assignment timeline and look at the kind of tasks you want to be working on. Like sketching your concepts out, brainstorming the ideas like we did in class today. Keep going with that. You know, don't just rely on what you did in class today. Try and come up with some as many ideas as you can. Look for similar examples to what you want to do online. That will be really useful to you in the brief, in the pitch document, because part of that is what are your influences. So if you can find similar examples, that's really useful. And start coding. Start making little sketches that do parts of what you want to do in your assignment.